Hello and welcome to another ASMR code video, and today, as you might see, we will be doing Advent of Code. It's December 1st today, and that means the first challenge of Advent of Code is live, and we already have a countdown to day 2. If you don't know anything about Advent of Code, you can check out the About page and read all about it. But basically it's just some open challenges where the challenges get a bit harder every day. So like towards the end, I don't know if I can still solve them, but we'll see. I never tried it before, so this will be the first, but day 1 should be fairly easy. I took a look at last year's challenges, and yeah, we'll just see how far we can get. So let's start with day 1. Alright, so that's challenge number 1. It's called Sonar Sweep, and there's always like this backstory or something to it that explains the whole challenge in a more story type of way. So you're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights, because of course it is, and it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report: 199, 200, 208, 210, 200, 207, 240, 269, 260, and 263. This report indicates that scanning outward from the submarine, the sonar sweep found depth of blah blah blah. You get the idea. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There is no measurement before the first measurement. In the example above, the changes are as follows. At first we don't have an increase, then it increases again and again, then it decreases, and yeah, you get the idea. In this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement? Alright, so to play, you need to identify yourself through one of these services. So that's because you can save your progress. You can upload your solution and then it will give you like the stars and stuff. And you can also get on the leaderboard, but you have to be really quick for that. Alright, so while I was registering, it started raining a lot more. I have no idea how this will end up on the recording, but I hope it's fine. So now that I authenticated myself with my GitHub account, we can get the puzzle input. Let me just do Control A, Control C to copy everything. And on my Colab instance, we can now get a new file and call it input.txt. and then we open it and save all the entries. We see that we have 2000 sonar depth measurements. Alright, so the first thing we do is read all of the measurements from the file into a list. So I always have to look this up, but we'll try. Measurements, and then we can cast them to an integer because they will be strings, I think. And we also do, I think, strip maybe for entry in lines. Let's see. So probably, oh, it ran. Let's see. Surprise myself there. Oh, they are there. Look, amazing. Let's see what the first entry is. Yeah, okay, so we have all the measurements in a list now, and now I guess we just loop through them and see how many increased. So I guess we save the previous entry, and for the start this will be just the first entry, and then for entry in measurements starting from index 1, because we don't need the first one. We also need a counter increases, and now if entry is bigger than previous entry, increases by 1, as the name says, and then the previous entry will be the current entry for the next iteration. Let's just run this and see what we got out. 1215, and now we copy this and check if the answer is right. We paste it in here and submit, and we get the right answer. Now we have 1 gold star, and we can continue to part 2. So part 2 says, considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of a 3 measurement sliding window. Again, considering the above example, and now it tells us A, AB, ABC, BCD, ECD. Start by comparing the first and second 3 measurement windows. The measurements in the first window are marked A, and the sum is 607. The second window is marked B, and its sum is 618. The sum of measurements in the second window is larger than the sum of the first, so this first comparison increased. Your goal now is to count the number of times the sum of measurements in the sliding window increases from the previous sum, so compare A with B, then compare B with C, blah blah blah. Stop when there aren't enough measurements left to create a new 3 measurement sum. In the above example, the sum of each 3 measurement window is as follows. And then it gives you an example. And And now we do the same thing for our input. So down here is part 2. Let's also mark this as part 1. First we need to create our sliding windows, and I think we can do this with the... oh, I need to import NumPy first. I mean, we can do it by hand, but there's also a nifty function that I want to remember to use. So np convolve, and then the input will be our measurements, and then the kernel or something, whatever you call it, that we want to run over it has to be once, and it has to be the length of our sliding window, which is 3 in this case. And I think the mode, I have to look this up, but maybe full, because we only want full sliding windows. And if we got this, then I think we have the sliding windows should be 2 smaller than the original measurements array. So let's do length, print length of measurements, and print length of sliding windows. It's 2 bigger, so that's not right. Maybe we need to do valid. Yeah, that should be right. So let's just check measurements 0 plus measurements 1 plus measurements 2. Okay, so that's the first 3 added, and then we can compare this with our first sliding window. Okay, so that's a float, but that doesn't really change the comparison, so we'll just keep it like that. So now we just do the same thing that we did up here. Good old copy and paste, but we do it with the sliding windows. And run this and get the increases. So that's 1150, and let's check if that's correct. And that's also the right answer. You are 1 gold star closer to finding the slay keys. You have completed day 1. So, as always, I will share the code on my GitHub, and maybe we'll see each other again on day 2. If you like this, let me know if you want to see a full series on this, or if you would prefer something else. And yeah, this is quite a short video, but I hope the other ones will be more challenging, and then we have a bit of a longer video. But I hope you enjoyed this nonetheless, and thank you so much for watching, and I'll see you in the next one. Bye!